UBM is an extracellular matrix, or ECM, that facilitates remodeling of site-appropriate tissue. In the 1950s, Dr. Alan Spivak, a Harvard professor, surgeon, and tissue engineering pioneer, conducted research into a salamander's ability to regenerate limbs. He found that a special component of the salamander's ECM was necessary to facilitate regrowth. That component is the epithelial basement membrane. This is the thin, delicate membrane of proteins that serves as a natural barrier to separate tissue layers. He went on to research porcine urinary bladder matrix, or UBM, one of the few ECMs that contains an intact epithelial basement membrane. Dr. Spivak recognized the potential of UBM in tissue engineering applications. In fact, more than 200 published research articles have investigated UBM in a variety of applications. How does Integra use UBM technology? Integra processes porcine bladders to remove cells and potentially harmful pathogens, leaving an ECM containing two innermost layers of the bladder intact. The lamina propria, which is rough and porous, allowing for the body's cells to infiltrate UBM, and the epithelial basement membrane, which contains a specialized protein composition, including anchoring-type collagens 4 and 7, and provides a surface for cellular anchoring and migration. The unique structure and composition of UBM differentiates it from other available ECM-based devices on the market and facilitates deposition of site-appropriate tissue. Tissue that resembles the surrounding tissue. So how does a typical healing process work? In the normal healing process, the body works to close disrupted tissues to prevent infection and further tissue damage. Unfortunately for adult humans, this will result in deposition of fibrous scar tissue with diminished biomechanical functionality. This process is regulated largely by the immune system, where the key players are macrophages. There are two main types of macrophages involved in the healing process, M1s and M2s. M1 macrophages are pro-inflammatory and are involved with cleaning up debris, while M2 macrophages are anti-inflammatory and are involved with tissue remodeling. While pro-inflammatory M1 macrophages play an important role in the early stages of normal wound healing, the ability of the body to transition towards a predominantly M2 pro-remodeling macrophage population is crucial. This is where UBM comes in. When applied to wounds or placed in the body will recognize any ECM as being a foreign body. However, UBM provides an environment in which macrophages are more likely to exhibit an M2 macrophage phenotype. Thus, the macrophages and other cells break down the UBM as they simultaneously lay down new proteins. Ultimately, these cells remodel the scaffold into a tissue that resembles the structure and composition of the native surrounding tissue. UBM medical devices maintain and support a healing environment by facilitating the remodeling of site-appropriate tissue. Comprised of naturally occurring UBM, they maintain an intact epithelial basement membrane and lamina propria. Integra offers the only commercially available UBM technology as a platform for medical devices used in wound management under the brands Cytol and Micromatrix, and for surgical soft tissue reinforcement under the brand name Gentrix. For more information, visit www.integralife.com.